So to begin, what I would like us all to do is to get on our notes and make a perfect square number list from 1 to 144. So let me help you out here. We have the number 1. We have the number 4. Everybody jot this down. We have the next number 9. Now we have the next number. Anybody? Not 10. 12? No. 16. Come on, guys. What's the next one? 25. And the next one? 36. And the next one? 49. Bless you. The next one? Anybody? 64. And of course there's more. What's after 64? 72? No. 81. Okay, and then 100. And then 121. And then 144. If you're wondering where the heck is he getting these numbers from, it's simply squaring a number, right? That's why they're called perfect square numbers. If you take the number 1 and square it, what do you get? You get 1. If you take the number 2 and square it, what's 2 times 2? It's 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 times 6, 7 times 7, 8 times 8, 9 times 9, and so on and so on. That's why these are called perfect square numbers, because they came from squaring a number. They're called perfect square numbers. Everybody agree with that? Everybody remember that? Good. So this is a very important fact right here. The square root of a perfect square number is a perfect answer. If you take the square root of 9, that's 3. The square root of 25, it's 5. The square root of 1 is 1. The square root of 81 is 9. The square root of 49 is 7. The square root of 36 is 6. When you take the square root of any of these guys, you get a nice, beautiful answer. Okay. Now, when you say, what's the square root of... actually, let me ask you this. What is the square root of 9? What's the square root of 9? 3. Why is it 3? Because 3 squared is 9. 3 times 3 is 9, right? Now, if I say, what's the square root of 20, then it's not a nice number. It actually becomes an irrational number. It's a crazy long decimal that goes on forever. It's not... there is no pattern. It's irrational, okay? So when you take the square root of a perfect square number, you get a nice, beautiful answer. When you take the square root of a number that's not a perfect square number, you get a crazy, crazy decimal. Anyway, simplifying square roots is pretty easy. All we need to do is remember these facts right here, that if you do have something times something inside a square root, you could split the square root, right? You could split it to each of the terms, okay? Example, right here. The square root of 18. Now, we know that the square root of 18 is not a nice, beautiful answer. Now, if I said, what's the square root of 16? The answer is 4. But this is not 16, this is 18. So when I say the square root of 18, it's not a perfect square number. You want to get a perfect square number in there. So you want to rewrite it with multiplication so you could get a perfect square number. So does 4 work? No, because 4 times something does not give you 18. So 9 times 2, 9 is a perfect square number. So I take the 18, rewrite it as 9 times 2, and then I take the square root and I split them to the 9 and to the 2. And now you could actually do the square root of 9, which is 3, and the square root of 2, you can't do it. You can't break it down any further. It is an irrational decimal, but I'm just going to leave it as 3 square root of 2. Okay? And that's what we call simplifying a radical. And of course, we could go backwards. If you have the square root of something times the square root of something else, if you see that it's convenient, you could put them together and put them underneath one square root. Okay? That's only if it's convenient to you. Like, for example, here, the square root of 8, that's an irrational number. The square root of 2, that's an irrational number. Okay? Now, if you actually did the square root of 8 on a calculator, you get a crazy decimal. The square root of 2 on a calculator, crazy decimal. But if you see that 8 times 2, if you put them together, 8 times 2 is 16, then you get the square root of 16, you get the actual nice, beautiful, natural number 4. So you could use this rule of splitting the square root or putting them together, all right? Right here, you're splitting them, and down here, you're putting them together. And it's the same thing, by the way, that only works with multiplication, right? Multiplication right here, or multiplication right here. Now remember, multiplication is the same thing as division, so this rule also applies when you're dividing. What do I mean by that? If you have the square root of something divided by something, you could take that big square root and split it, square root on top, square root on the bottom. Okay, so an example, the square root of 9 over 25. First of all, 9 over 25 is a decimal. And if you take the square root of it, I mean, that's kind of ugly. But if you have the square root of the top and you split it to the top and split it to the bottom, you take that one single square root and split it to the top and bottom, then you'll get a nice, beautiful answer, 3 over 5. Okay. Likewise, you could have it separate where you have the square root of something on top, the square root of something on the bottom, and you could put them together underneath the one square root if it's convenient for you. And right here it is convenient because 8 divided by 2 is 4, and the square root of 4 is 2. On this next section of our notes, if you scroll down a little, it says, fact, if you do not have a perfect square number, break it down with multiplication to get a perfect square number. That's how to simplify, all right? So here's an example, the square root of 20. You don't want to break it down to 2 times 10 because 2 is not a perfect square, 10 is not a perfect square. You do want to break it down to 4 times 5 because 4 is a perfect square. And when you split the root, the square root of 4 is a nice, beautiful number 2. And the square root of 5, you can't break it down any further. So if we look at number 1 right here, what are we going to break down 50 to? Are you going to break it down to 5 times 10? No, because 5 is not a perfect square, 10 is not a perfect square. Give me a perfect square number that works to be able to get 50 when you're multiplying. 25 times 2. So we're going to, and I'm going to jump straight to the splitting part, 25 times 2. I already split the square root. And the square root of 25, the answer is 5, and the square root of 2 is going to stay the square root of 2. Now, of course, you're supposed to try to break this down further, but you can't. The square root of 2 is as simple as it gets. And yes, technically it's still an irrational number. Okay, if you were to do square root of 2 on the calculator times 5, you're going to get a long, crazy decimal that has no pattern, that continues forever. Okay, how about the square root of 72? Now, the best way to go about this is to make a list of perfect square numbers. So I have the first part of the perfect square number list up there. You have 4, 9, 16, 25, 36. The next one's 64, and I know that 64 times something won't give me 72. So all I really need to look at are these numbers. Will any of these numbers work to be multiplied by a certain number to give me 72? What would it be? I mean, 4 will work, but 36 is definitely the best answer right there. Even 9 will work, right? 9 times 8. But the better, you want to go for the highest perfect square number. So even though 4 and 9 might work, 36 is the best number, 36 times 2. So let's use that. 36, put the square root on it, times 2, put the square root on it. You're going to end up with 6 square root of 2. And that's what we call simplifying. Yes. And for the sake of time, let's skip number 3 and just do a couple of these down here. Like number 4, the idea is you could split it, the square root of 4 over the square root of 9. That becomes 2/3, and that's your final answer. For the sake of time, we'll do a couple more. Okay, and then when we look at the next one, number 5, if I do the square root of 9 over the square root of 25, what's my answer going to be? 3/5. Easy peasy. Now, number 6, would you split the square roots on number 6? Would you do the square root of 28 and the square root of 7? That would not be a good idea because the square root of 7 is an irrational number, doesn't end up with a nice answer. Or the square root of 28 for that matter is not a nice answer, right? Now, think about this. Inside the square root, what's 28 divided by 7? 4. So you really have the square root of 4. And what's the square root of 4? Final answer is 2 on number 6. So sometimes it's convenient to split the root. Sometimes it's not convenient to split the root. Take a look at this next fact right here. In other words, okay, actually not in other words, but the square root could also be rewritten as the power of 1/2, okay? The square root could be rewritten as the power of 1/2. So whenever you have the square root of x to any even exponent, you end up dividing that exponent by 2 and you get your new power and you're done. So example number 1, the square root of x to the 6th. That's really, let me rewrite this so you guys can see what I'm talking about. X to the 6th, instead of the square root, I want to put the power of 1/2. Okay? Because, and this is a fact right here. When you say why 1/2, this is the fact. That a square root symbol is the same exact thing as the power of 1/2. That's how it is, right? It's kind of like me saying the number 3 is the same thing as 3 over 1. You guys agree with that, right? It looks different, but it's really talking about the same thing, right? So a square root symbol could be rewritten as the power of 1/2. Just think about that. So the square root of x to the 6th could really be x to the 6th to the power of 1/2. Now we should know exponents from Algebra 1, that when you have a power to a power, what do? You multiply. And what is 6 times half? 3. So you really have x to the 3rd power. Okay? And down here, when I broke down this fact, it says, in other words, when you have the square root of x to any even exponent, simply divide the exponent by 2. Right? Even if it's odd, you could still divide by 2. It's just you don't get a nice answer. So let's take a look at number 2 here. You could think of it as 3 squared to the 1/2 power. That way you could think power to a power. What do you get? What's 2? What's the power of 2 times 1/2? 1. So you really get just 3 to the 1 power, which is just 3, correct? Okay, so we already knew this though, because what's 3 squared? What's 3 squared? 9. And what's the square root of 9? 3. So we already knew that, right? It's just different road to the same place. But I just want to show you that the power, the square root really becomes a power of half. So a lot of people, instead of dealing with square roots, they like rewriting the square root as a power of 1/2, and they rather deal with exponents. So look at number 3. Remember, the square root is really the power of 1/2, right? So you really have 2 to the 6th to the 1/2 power. What's your final answer going to be? 2 to the 3rd. And what is 2 to the 3rd if you actually work it out? 2 times 2 times 2. 8. Boom. Done. Now another road to the same place would be 2 to the 6th. That's 2 times 2 times 2 times 2 times 2 times 2, 6 times. And that'll give you 64. And the square root of 64 is 8. How about number 4? Well, you really have x to the 3rd to the 1/2 power. So you really have 3 times half. So that would be x to the 3/2 power. And that actually becomes, well, let me do this. And I think I'm spending way too much time on this. Let's go back to this original one, x to the 3rd power. Let's rewrite it as x squared times x. Now, why would I do that? Because when I split it and say x squared, the square root of x squared times the square root of x, I could actually do this first square root of x squared, which is what? X. And the second one, you just leave it alone. So your final answer there would be x square root of x. So let's practice simplifying. I'm going to give you guys a couple of minutes here, and I'll just put the answers up. All right, for the sake of time, number 1, the answer is 3. Number 2, the answer is x. Number 3, you break it down to 4 times 2. You end up with 2 square root of 2. Number 4, we just did number 4. Pick one. 14. So when we take a look at number 14, we have a 3 on the outside. This is a regular number 3, and it's really saying 3 times the square root of 12. Okay, so let's focus in on the square root of 12. Now 12 is not a perfect square number, right? So you want to break it down with multiplication so you could get a perfect square number. That will be 4 times 3. 6 times 2 won't help you. 4 is a perfect square number, so that's what we're going to go with, 4 times 3. Split the root. Put the square root on the 4, put the square root on the 3, and let's not forget to bring down that times 3 that's out in the front. So the whole purpose of getting a perfect square number is to be able to do that square root. So you're going to end up with 3 times 2 times the square root of 3. So your final answer will be 6 square root of 3.